Here's a tool that I've built that you can use to calculate the confidence of your A/B test. The typical scenario is that you have a website and you're trying to get the users who visit the website to do some kind of action. So it could be a download, it could be placing an order, or it could be even clicking on something. So you often have all these questions about how do I design a website that best converts the users? And you can have your questions like what fonts to use, what type of site design you have, what color of the different elements. So a way to approach this is typically to do what it's called an A/B test. Okay? This A/B test is also known, or other names for the same approach is an experiment, or in the field of medicine, this is also called a clinical trial. When you have a new medicine and you're trying to figure out if this new medicine works better than no medicine or even to an old medicine. So the main idea here is to have two groups and then compare two groups. So typically you start with the existing version of something. Let's go back to the example of doing a website. And let's say you have a button, the control. This is a bit of terminology that I'll introduce while I'm explaining, but in a A/B test or in an experiment, there's typically the control group, which is, you can think of an existing version of something. And in our case, we're going to look at the button of a website. But you kind of are thinking that, it's a new year, I want to test a new color. Maybe this year is going to be the year of green. So let's try to do a new button, maybe with the color of green. You wonder if this new color will actually help get users to convert more. So you create this alternative to your website, which is a website that has a button with the color green. And this is called a treatment. So so you have these two. This is the experiment that you typically run. You'll have a website, the original one, which is called the control, which is have a blue button, and then you have this new site that has a green button. And then you put the two versions live, or what it's called like running on your website, but then you send some users to one version and the other users to the other version. So in this case, let's look at the concrete example. And in this case, you would be sending 2,000 users to your old site, the one which is the control, it has the blue color. And then you're going to be sending 500 users to the new version, kind of the new site, which has the green color. And then the question at the end is, you want to see if you end up with more conversions. This terminology also called conversions, which is converting user from seeing the site to then doing the action that you're trying to. And in the big question, the big hypothesis, whether green leads to more conversions than blue. Okay. So if we look at the numbers we have here, we see that out of those 2,000 users, 198 clicked on that blue button for the control version, and we get a conversion which is about 10%. And then you can compare with this new version, the green one, which out of 500 users, 60 clicked on that button. Okay, so you get a conversion of 12%. And right away you get this number and you're like, yay, 12% is an increase of almost 2%. Maybe I was right. Maybe this is the year of the green, right? And now I'm going to jump into this tool so we can also see the tool and we can see the same numbers here calculated. So the tool works in the same way, where you put the number of how many you had users on the control group, how many conversions you have. We have that 9.9. And then we see the same here for treatment. You enter how many users were exposed to that treatment, and then how many got converted. And we see that we are seeing 9.9 versus 12 here. Okay, so at first you might think, oh wow, I got more people on the green. So you might be very tempted to go towards putting all your site green. But then, you kind of start to wonder, 60 users is not that much. And the difference is not that big. I mean, it's 2%. But, if I put, for example, here 50 users, we get a conversion rate which is about the same as the control, right? So it's like 10 users making a difference. And at this point, typically all the doubts start to creep in. Like, is it really 10 users significant? Can I trust the results? Is this just a random fluctuation in the data? So, and this is where this calculator comes handy. And this is a known problem in the field of statistics. It's a very well-defined problem, and that says that in every test you run, it is actually totally expected to have some natural fluctuation in the numbers and in the conversions. So given that random fluctuation, how do you know if you can trust it, right? So this is what this calculator does. Once you have the numbers input here, you basically you only need to look at this section that says whether this is significant or not. And basically the question is this the difference between these two groups is significant or not? And it tells you no. And that means when it tells you no, it means it's just the difference is because of random fluctuation. So you cannot trust that as being a significant difference. Let's say instead we had, for example, here 70. And to use this tool, essentially that's the most straightforward way to use it is just to put those four numbers and get that result, okay? And in this case, 70% would be already a 14% increase for the treatment. And so the tool is telling you that yes, with this difference, with this number of users, you do have a significant difference, and you can assume that green is the right thing to do for the site to be able to have more conversions. Now, that's the basic usage. So let's now touch on a couple of things more that you can use with this tool, and it's worth noticing. So the first one is that that you can leverage the calculator here to input some numbers to get a feeling of how many numbers and how many users do you need to be able to have a positive, right? So you can go and play here with the numbers, put 65, for example. Let's see if 65 is still significant. Yes. But if you put 55, then it's not. So this is a way to play with the tool, and you can have an idea of how many users do you need. The second thing is the number of users is very important. So let's just think from the intuitive point of view that when you have very low number of users, the difference between controlled treatment can be decided by just a few users, right? 2 or 3 or 5 or 10 users. And intuitively, we kind of think this is too low. I'm not sure I can trust when the whole decision is just made by those, small amount of users. So in general rule, the more users you can have here, the more likely you're going to have a significant difference. So the more likely you're going to see that turning into green. And And we can go back to our original example. For example, when we had here 500 users and we had 60 conversions, we had about 2% difference from the conversion of the control group, but we didn't have enough confidence in the test. It was not enough. And it's not necessarily only about the percentage of the difference, but it's even more based on the number of users. So let's say instead we have, instead of 500, we have 5,000, and instead of 600, we have, or instead of 60, we had 600 users converting. Let's give it a second to calculate. See that the percentage difference is the same because we are still converting 600 out of 5,000, which is 12%. But because the number of users increased a lot, it just means that more often we saw that consistently, that difference, that 2% difference consistently. So we can think of that as an intuition behind it. And we see that tool in the calculation reflects that. So the more number of users you have, the more the best it is, and the more likely you're going to have that confidence and that result turning into green. And the last thing is that there is here, although all you need is that box of the saying yes or no, you do have here an extra box or an extra bit of information that you can expand to see, and it has the technical lingo of things like the p-value and the z-stat. So these are the stats that are part of the statistics field when you calculate something like this. And you also have here this representation, this chart of the representation of these two, the control, these two lines, these two curves. One represents control, the other treatment. What you typically want to see is the more separate they are, more likely they are that the difference is significant. When they overlap, when they come very close, more likely that they are from the same distribution, and it's just the result you had is not significant. It was just a random variation. Yeah, so you can use this as an extra, if you know about this area or if you are into this, you can see here for more information. Yeah, enjoy. I hope this is helpful.